just a minute. Thank you for watching the video, though. Okay, so we've got our practice quiz. We understand that while there are two here, that's just so we can practice both kinds. Tomorrow, or whenever, Tuesday, whatever, you will only have one problem. You have your note card, so you will have to decide whether you're going to be using the PV or the FV when you read your problem, okay? So I'm going to write my two formulas up here. You got them on a note card. I have them in my notes. Because I don't have these memorized. All right, so let's read the first problem on the practice quiz. And let's see if we can figure out. Try to stay awake. Let's see if we can figure out whether Solomon is going to use FV or PV. So Solomon is saving for his retirement. He makes weekly deposits of $10 into an account paying this % interest. How much will he have in 47 years? What's special about 47 years? Solomon's probably 18 right now. So how old will he be? 65? Yeah. Which is like sometimes a retirement age. So that's why I picked 47 years. Okay? All right, so here we go. Is Solomon, who's saving for his retirement in the future, is he going to use FV or PV? FV. So if your problem that you get on your quiz, and the quiz is only going to be one problem, just like this, I ran them off too, just like this. When you get your problem, you're going to have to decide, is this saving for the future? If it is, you're going to use this formula. What?
You have to memorize the two formulas.
Okay, what did I tell you? All along, what have I said?
I'm not sure.
Okay, well, where should these formulas be? On your note card. Yep. And you're going to have your note card for the test. You've had it for all the quizzes. You're going to have it for the test. You're going to have it for the final exam. Okay, got to have our note card. Okay, so here we go. So Solomon's using this formula. All right, so where do all these numbers go? Where does the $10 go?
And R.
Right, the big R, right?
Yeah.
Because the big R is the payment.
That's the amount of payment.
That's the payment. And you don't need to put the .00. I think that's just going to clutter things up. So I'm just going to put 10 there. My interest rate, what am I going to put in for little r? 0.01875 divided by
47.
No, not 47. You don't divide by the number of years. By what?
52.
52, because n is the number of times per year. So we're going to divide by 52 because Solomon is making monthly payments. And then NT, what's that going to be? 52 times 47. So 2444. Over 0.01875 divided by 52.
Yeah, that's right. Okay.
Everybody good so far? Okay. All right. Well, I should put that away. And I'm looking for this. This is what I'm solving for. All right. Well, this is kind of a mess, right? So let's see what we can do with that. Let's see. 1 plus 0.01875 divided by 52. That's not a nice number, so I'm going to go ahead and keep some decimal places. So this is 1.00036 to the 2444. And you're free to keep as many decimal places as you want. The more, the merrier. And that's going to be divided by 0.00036. take that number right there. I'm gonna raise it to the 2444 power and subtract 1 and hit equals. That's the tricky part with this formula. After you do the numerator, you have to hit equals and then divided by 0.00036. Did you get like 3,917? Then you gotta take that times 10. Because we gotta multiply the bracket times 10. So Solomon is going to have $39,170.34. Now, the formula will be on your note card, right? So you get 3 points. This is a 6-point quiz. 6 points. You get 3 points for picking the right formula and putting the numbers in the right space. Where do you think you get the other 3 points from? Typing it in right. That's right. So make sure you should be sitting here typing this in with me and getting that answer.
I am not getting .00036.
Okay, I want you to type 1 plus 0.01875 divided by 52.
I did that.
Okay, do it again, because you're going to get 1.0036. Anaya?
I got your answer. The only difference is my decimal is .0, so my answer would be 3,917.03.
Did you round like I did right here?
Yes.
Okay, do it again then, because it shouldn't be off at all. 39170.34, yeah. Okay, did you get it now, Bryce? Yeah. All right, flex would be a great time if you're having calculator issues, because I don't want to tie up our class time with that. So if you're not getting this, then you should get in here so we can sit down and look at your calculator and figure out what's going on. All right, next problem on the practice quiz. Remember, you only have one, but you don't know which one you're going to have. Let's look at the Mamuna problem. Mamuna owes this much money on her Visa card. She vows to stop using the card and she wants to pay it off in 3 years. The interest rate is 19.2%. What are her monthly payments? So when you read that question, does it occur to you that this is the formula you need to use? This is the formula we use when we're paying off a debt. This is the formula we use when we're investing for the future. All right. Do we know how much the debt is? Do we know the present value of the debt?
Yes.
Yes. It's $354.10. We do not know big R, because what's big R?
That's what you're trying to find.
That's the payment. How much does she have to pay? That's what I'm trying to find. Everything else I should know. My interest rate is 0.192 divided by monthly payment, so divided by 12. What power? Negative 36. 12 times 3. You okay with that setup? Everybody good to that point? Alright, so now we're going to type it in. I'm going to clean those things up. I think I rigged these so they come out a little bit better. Okay, so 35410 equals R times 1 minus, this is 1.016 to the negative 36. you sure you're getting that? All I did was simplify the parentheses right here and this guy right here. You typing this in with us, Emmett? Everybody where I'm at? Okay, probably now type in that big bracket and see what happens. So remember, when you do 1 minus 1.016 raised to the negative 36, hit equals before you hit divided by 0.016. I got like 27.
1, 2, 5.
Yeah.
0.
Yeah. Now, that's this. I just typed this in, right? I need to figure out what that is, though. So
Divide.
this is not the answer. I'm going to have to take 354 and divide it by this, right? So remember how we do that? We just typed all this in. It's right here. So now I do 354.10 divided by second answer. And I got, her payments are going to be $13.02.
So 3, 4.7.
So we take this big bracket value that we got, and we do 354.10 divided by that number. So divided by second answer.
Oh, this is weird. That's not recording. It's like on the sign in the iTunes store.
Oh, it still records even though it says that. See how it's still running? It's still recording. You just can't see what it. Thank you though for telling me that. I don't know why it always says that message. I don't even know how to sign into iTunes. Okay. So I would suggest that sometime between now and Tuesday, you pull this paper back out, this practice quiz paper, and you crank in these problems again just to make sure you remember how to do it. Because on Tuesday, we have one little problem there too. Okay? And we'll probably run into some of these in our review too, so we'll get some practice that way too. All right, everybody clear on that? All right, so the last thing we have to do before we go to our practice test is finish up our notes. So you'll remember that yesterday we actually finished up everything but the very last page, which was the review, some review problems. So in our notes, we should be on the very back where it's typed. And you are only responsible for the circled ones. And I think we got through number 1 yesterday. Well, I really shouldn't erase those. Is everybody on the back side looking at problem number 2? I don't want you to be confused. Since we are aligning ourselves with the International Baccalaureate curriculum, sometimes in their problems they use like unfamiliar words. And so Saul bought a new bicycle for US $350. Forget the US part, it's $350. Don't be confused by their random stuff. All right, so Saul's bike costs $350. The value of the bike decreases by 12%. What will be the value in the 5th year? So it's decreasing by 12%. Are we using FV or PV or A equals P times 1 plus R over N? Are we using any of that stuff? No. Those formulas are very specific. We want to know if we keep knocking off 12% every year, what will be the value in the 5th year? So what do I need to do? 350 times what? 0.88 to the fourth. That's going to be the 5th term, right? So we type it in, write down the answer, and move on. 350.88, $209.89. Everybody okay with that? And let's jump down to number 5. The school fees increase each year by the rate of inflation. When Barnaby joined the school, the fees were $9,500. Forget all that other stuff, $9,500. At the end of the first year, the rate of inflation was 1.16%. So that means it's going up 1.16% every year. Find the cost of the school fees for the second year. Okay, well this is what it was in the first year. All we have to do is what?
Add 9.
Multiply it by 1.0116. Isn't that how you get a 1.16% increase? If you're confused by that, what if it were a 1% increase? Just a plain 1. Wouldn't that be 1.01? So I'm just adding on the extra decimal places. So in the second year, the school charged $9,610.20. Is that right? All right. The following year, the rate of inflation was 1.14%. So what did it cost that year? Now what am I going to do? I'm going to take that answer, right, and multiply it by what? 1.0114. Don't make it hard. Use your common sense. So take that answer times 1.0114. So I think we paid 9719.76. Is that okay? All right, that was 5. Now 6A. Not sure how to pronounce her name, or his name, I'm not sure. I'll just say we invested $3,000 in a bank that paid 2.35% interest, compounded monthly. We should underline that word, compounded. Find how much we had in the bank after 6 years. Compounded. Do we have a formula for that?
Yes, we do.
We do. So let's write down that formula. You have your note card. So for problem number 6A, the formula we're using is your compound interest formula. We deposited $3,000, so that's P. The interest rate was what? What do I put in here? 0.0235. Divided by 12. raised, this is after 6 years, so 12 times 6, 72. Is everybody good with that setup? All right, let's type it in. This is one we don't have to do anything tricky. We can just type it in exactly the way we wrote it. We don't have any round off there or anything. It just comes out beautifully. I got $3,453.80. Anybody match that? As tired as you are, and as much as you just want to sit there and enjoy watching me doing the problems, you really need to practice typing these in. It's going to stink if I have to take off a bunch of points because you don't get right answers. All right, any question about 6A? All right, let's look at 9. Natalie, or whatever that is, borrows $6,500 for a motorcycle. The loan, oh, here we go. The loan is for 5 years at 2.5% interest per year. Find how much Natalie's monthly payments are. Okay, so you've read the problem. You're looking at your note card. Which formula are you going to use to figure this out, Toby?
Oh, you're gonna use the PV formula.
Yes, indeed we are. Thank you. Perfect. So we're going to use the PV formula. So this is practice for our quiz next time, because this is the one you're going to have to use this one or FV. All right, does everybody understand why we're using PV? All right, so let's plug in stuff. What do I do with the 6,500? Is 6,500 go in for the R? No, 6,500 is the present value of the loan. This is 6,500. What does big R, what does the big R always stand for?
Amount of the payment.
The amount of the payment. Don't put anything in this spot unless that's how much you're depositing every month or whatever. Okay? So isn't that what I'm actually looking for? All right, so 1 minus 1 plus. Our interest rate is
0.025.
0.025 divided by 12, raised to the what power? Negative 60. Remember, this formula has a negative in it. Does that look okay to everybody? All right, take a minute and see if you can type that in. Let's see if we all can come up with the same answer. also accept $115.36. That is the answer you get if you don't do this roundout, if you just put it in exactly as it is.
But only it was only one card.
Alright, so once again, if you're not getting that, you might want to stop by during flex and work on that a little bit. Make sure you got that under control. Because not only will it be the quiz question, but it'll also be a test question, obviously. So you need to make sure you got that. Alright, number 10. The population of rabbits can be modeled by the function. Now, kids, don't let this confuse you. This is actually easier. They are giving you the equation to use. 24,000, 1.12 to the x. They are giving you the formula, so you're not looking at your note card. They're giving you the formula for this rabbit population. And x is years. And what will y be then? Read the problem. What's y going to be? Or f of x, y?
No, number.
The population of rabbits. So y is the number of rabbits. Yeah. The equation tells you how many rabbits you've got, folks. Find the number of rabbits after 5 years. Well, that's easy. All we have to do is what? If we want the number of rabbits after 5 years, we're just going to let x be 5. Now, these are rabbits, not money. So make sure that when you write down your answer, you're rounding it off to the nearest rabbit. So oh my goodness, I have 42,296 rabbits. No point. 42,296 rabbits. Is that okay?
Rabbits.
Calculate how long it will take for the population of rabbits to double.
Oh, sweet.
So again, here's your equation. How long will it take for the population of rabbits to double? All right, so what do I do? Jacob?
Start by putting in 148,000.
Right here, right?
Yeah.
So the number of rabbits, which is y, is going to be 48,000. That number is still there in the equation. Oh, by the way, how did Jacob know that we're starting with 24,000 rabbits? Because when we write equations like this, isn't that always the starting value?
And that's the end value. It's y.
And the end value is y, yep. So we want to end up with 48,000. If we start with 24,000, 1.12 to the x. When? How many years? X. All right? How do we solve that?
Divide by
Divide by 24,000. So that leaves us with 2 equals 1.12 to the x.
They take log.
Now we take the logarithm of both sides. Do not forget you're taking the logarithm of both sides. That's the only way that you can do the next step, which is what? No, not dividing. You gotta do something first. You gotta pull the x out in front. That is why you need the logarithms. You can't solve it when x is up top. You have to get x down. So one of the properties of logarithms says you can do that. Now we divide. What will I divide by?
Log 1.12.
Now, this is years, so we can go ahead and have a decimal on our answer. These are the ones, I know you're sick of me saying it, but I'm gonna keep saying it. What do I have to remember to do? Those parentheses. So X will be 6.12 years. Everybody okay with that? Right? We do that if we are finding a term in a sequence and we're using a formula that's not given. This formula is given. That's X. If we're using the formula on our note card, if it just says, here's a sequence, when will you end up with twice what you started with, then you use the formula on your thing, okay? They have already built that into the formula though, so that's why we're just using theirs. All right, where am I? Number 11. The temperature of a cup of soup can be modeled by this equation. Now again, they're giving us the equation to use. You aren't modifying it. You're not doing anything. It says the temperature is 21 plus 74 times 1.2 to the negative x. X is minutes and T is temperature. So if the T bothers you, you can make that Y. Y will be the temperature. You don't need to be confused by that equation. They gave it to you. Find the initial temperature. Now be careful. The initial temperature will be the temperature after how many minutes? 1 minute? Is that the initial temperature? 0 minutes. Isn't 0 the starting point? If we put a 1 in here, that would be the temperature after 1 minute. We don't want to know the temperature after 1 minute. We want to know the temperature after 0 minutes. So we're going to put 0 in for X. Okay? Now, what's 1.2? Now, actually, you have a calculator, so you could type that in. But 1.2 to the 0th is 1. So this is 74. And then we got to add 21. So it would be, what, 95 degrees? Is that right? Now, again, you do have a calculator. So if that, what I just said confuses you, type that in. Just like that. And you should get this. In general, if you want the initial value, you're going to let time be 0, x be 0. Okay? Everybody good with A? Okay, B. Find the temperature after 10 minutes. So I'm just going to put 10 in for X. Now this one I cannot do. Wait, that's negative 10. Sorry, it's negative X up there. I cannot do it without a calculator, so I'm just going to type it in. And if I type in exactly what I wrote, then you can do it that way. So 21 plus 74 parentheses 1.2 raised to the negative 10. Oh gosh, I got 32.95 degrees. Is that okay? minutes it takes for the soup to reach 40 degrees.
Oh, so you would put 40 in for tea.
So I put 40 in for tea. So my equation looks like 40 equals 21 plus 74 times 1.2 to the negative x. Does that make sense to everybody? T is temperature, and 40 is the temperature. Lordy, lordy, lordy. How do I solve this? What do you think?
Can you add them together and divide?
Can we add these two together? No, because this one is hooked to something. So you can't do that. Subtract the 21. Let's get rid of the 21. So 19 equals 74, 1.2 to the negative x.
Divide up to 74.
Divide by the 74.
And then use logs.
So I have 19/74, which is going to be a yucky number. I'm going to keep it in my calculator though. So 19 divided by 74 is 0.25675. It's a whole bunch of stuff. 1.2 to the negative x. Now, I'm not going to panic. This number is on my calculator. I'm just going to leave it there for a minute. Now, what do I need to do? Log both sides. Is everybody good with that? Look where your variable is. Now log both sides. And why did we do that? So that we could pull the negative x off. And then what are we going to do? Divide by the log of 1.2. Now this is where that's going to leave us with negative x. Now when I type this into my calculator, this number is still there, right? So guess what I'm going to type? Log second answer. Close the parentheses. Divided by log 1.2, and I got negative 7.46 years. Oh, not yet. But negative 7.46, it's not years, it's minutes, isn't it? Negative 7.46 equals negative x. So dividing out the negative, x equals 7.46 minutes. Is that okay? All right, now I need your thinking caps for a minute. Write down the room temperature. So you got this hot bowl of soup sitting in your room. The temperature goes down, 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 right? Eventually, I mean, it doesn't keep going. I mean, imagine a bowl of soup sitting here. It's not gonna all of a sudden freeze, right? It's gonna go down till it gets to the temperature of the room and it's gonna stop, right? That's the temperature it's gonna be. Anybody want to take a wild guess looking at the equation, what the temperature of the room is? I thought I heard somebody say it, Will. That's a good guess, but no. The temperature of the room is 21 degrees. Now, how do I know that? Because Does it make sense to you? Look, just based on what you've done already. This was the temperature after 10 minutes, right? After 10 minutes, it was all the way down to 32. After 7 minutes, it was down to 40. So 7 minutes brought it down to 40. 10 minutes brought it down to 32. So as this gets bigger, the temperature is just going to keep dropping down, right? But whatever this number is, what's it always going to be added to? 21? So this is just going to keep getting smaller and smaller and smaller. Remember what a negative exponent means? This is 74 divided by 1.2 to the 10th. If I waited 20 minutes and made that a 20th, this is a big number. 74 divided by that is just going to get smaller and smaller and smaller. You make this a 200, smaller and smaller and smaller. Well, this is getting smaller and smaller, but I'm always having to add it to 21. So this is the baseline temperature right here. This is the room temperature. So if the equation had been this, it doesn't matter. The room temperature would be 18. That's a tricky question. Tricky. All right, let's do one more. Now that we've completely fried your brains, let's try one more. Oh, shoot, will we get 2 done? We're almost done with this sheet. An exponential equation is this. So this is not a word problem. This is just the math. 4 times 2.3x plus 16. Now I went ahead and wrote it without the times sign. I put the parentheses in there. Does that confuse anybody? A, write the equation of the horizontal asymptote. It's going to be y equals. Now this goes back to something we talked about one day. Every exponential that you ever look at, the horizontal asymptote is going to start at 0. The only way to change that, so when they say what's the horizontal asymptote, you should say y equals 0. Unless they put what into the equation and add or subtract on the end of the problem. Because what does an add or subtract on the end of the problem do? Moves it up or down. So this moves up 16. So the horizontal asymptote is supposed to be at 0, but because of that plus 16, the whole graph has been moved up. So your horizontal asymptote is at 16. That's like the room temperature. The room temperature is 16. All right, and then B, the coordinates of the point where the curve cuts the y-axis. That's their fancy way of saying what's the y-intercept. And I'm going to be ticked off if nobody can tell me how we find the y-intercept. How do we always find the y-intercept? Plug in 0 for x. That's exactly right. Thank you, Tori. So I'm going to plug in 0 for x. So 4 times 2.3 to the 0th plus 16. What is 2.3 to the 0th? 1 times 4 plus 16? 20. The y-intercept is 0, 20. Kids, in terms of the soup problem we just did, the asymptote is the room temperature, and the y-intercept is the initial temperature. So the soup started out at 20 degrees, and it won't go below 16, because 16 is the room temperature. All right, one more. Let's get it done. We're awesome. The spread of a disease can be modeled by the equation y equals 4 plus e to the x. This is Euler's constant. We're not bothered by it. plus e to the x. It's just a number. We know how to find it on our calculators. Find the number of people with the disease after 7 days. Find the number of people with the disease after 7 days. Well, it tells me that x is days. So y equals 4 plus e to the 7. So here we go. 4 plus, how do we get e? Second ln 7. And there are 1,101 people. Now again, you gotta round that off, so I'm not gonna count it wrong if you put 1,100, because it's 1100.6. So an argument could be made either way. I'm saying 1,101 people. Alright, and then the last one, find the number of days, here's your equation, it takes for 25,000 people to be infected.
25,000 for what?
So 25,000 equals 4 plus e to the x. Watch it now, that's a plus. So what's the first thing you're gonna have to do? Subtract 4. So 24996 equals e to the x. Now what? Log both sides. Remember, e is just a number. We're not confused by that. E is just a number. So the log of 24996 equals x log e. And the answer to the question will be the log of 24996 divided by the log of e. So for those of you that are still with me, I'm going to go ahead and type that in. Log 24996, close parentheses, divided by log, how do I get e again? Second ln 1. And the answer is 10.13, is it years? Days. 10.13. Wow, that disease is spreading fast. All right, guys. Oh, wait, it's like Friday. Let me get the video turned off. Emmett, you gotta be in charge of this, man.